I'm going to put up the answer for these. And then you tell me what what you want to see. You have to show the work, so you have to show show these steps. So actually, you know what? I'm going to show exactly what I expect to see. If I don't see this, you're not going to get the full credit. You just put an answer, good for you. I have no idea how you got it. It's a take-home quiz. So take your time. You know what I expect from you. First of all, I expect to be able to read it. That's number one. Number two, I expect to see step by step. Substitute, then simplify. And then final answer at the bottom of the line. So G of 24. So all we're going to do is replace the x with the 24. So this would be square root and then 24 plus 12, which is square root 24 plus 12, that's 36. And the square root of 36 is 6. That's all you would have to show me. Down over here now, you put your final answers. G of 24 equals 6. That's what I'll expect to see on your test. Just like that. Substitute, simplify. G of -3. Substitute, replace x with a -3, so this is equal to the square root, -3 plus 12. So that's equal to -3 plus 12 is the square root of +9. And the square root of +9 is 3. So G of -3 is equal to 3. And then along comes x minus 8. G of x. And of course, the boxes are going to be big. The whole thing takes up one whole page. Okay, so we have G of x is square root of x plus 12. And we want to evaluate G of x minus 8. So the first thing you want to do is substitute x minus 8 for the x. So if x minus 8 replaces that x, then x minus 8 is going to replace all the x's. So G of x minus 8 is now equal to the square root. This x right here is now x minus 8. And then whatever goes in, you add 12 to it. So this x was a plus 12. Now I'm replacing it with x minus 8, but it's still a plus 12 afterwards. So we simplify. G of x minus 8 is equal to x minus 8 plus 12 is the square root of x plus 4. That's all you can do. You can't go any further. That's as far as you can simplify. That's all you have to do. That's what you have to show me, though. Substitution. So that x is replaced with an x minus 8. And then what happens after that? You add 12 to it. What does this equal? It equals x plus 4, and then you can't go any further. No, you can't take the square root of 4 because it's addition. If I gave you, let's just say the square root of 9 plus 4. That does not equal the square root of 9 plus the square root of 4. You can't split the addition up. What's square root of 9? 3. And what's square root of 4? 2. 3 plus 2 is? 5. Or what's 9 plus 4? 13. Is the square root of 13 the same as a 5? No. The square root of 13 is about 3.4 something. Actually, even a little bit bigger, 3.7 something. 2.6, 2.7. Remember, you take the square root of something, and if the answer is 5, then what is in here? The square root of what number is a 5? 25. The square root of 25 would come out as a 5, and that's not 25, it's 13. So you can't just split up the addition and say it's the square root of each one, then you just add them together. It doesn't work that way. That's why I get paid so much money to teach math, because people just want to keep doing this. Make it up as you go along. Because, yeah, that's kind of what I think people would just do. Makes sense. But that's not true. If you're going to make it up as you went along, probably would try to do it that way. Keep it simple. But it would never be right. You got to follow rules. Rules are in place because these things have to be the same all the time. There's correct and there's not correct. So that's all you can do. That's as far as we go. It only undoes perfect squares. That's not a perfect square. X plus 4 by itself is not a perfect square. Okay. Find the domain of the function. Write the domain using interval notation. You must show all steps to receive full credit. So domain. This is what I showed you last week. Double check here. And I think I need to post. And I will post. Got to remember to post. This. Finding the domain step by step. We went over it. I showed it to you. Talked about it. But I'm sitting there thinking, trying to remember what I have attached and what I haven't attached. It's like the brain is muck. Two things can cause problems in the domain right now for us. A 0 in the denominator or an even root of a negative number. So the square root, sorry, an even root, yeah. So a square root of a negative, a fourth root of a negative, a sixth root of a negative. And I promise I'm not going to give you one of those. It's going to be a denominator, and you have to worry about zeros. So bad for domain, a number over 0. Ask yourself this question. Is there a possibility that the denominator of a function could equal to 0? If the answer is yes, the domain is everything except that number. So you have to figure out what that number is. So we're looking at this. Denominator is 4 minus 9x. The numerator is perfectly fine. The numerator can equal 0 all day long. You can't divide by 0. 0 in the denominator is bad. Can't divide by 0. So what you have to do is you take the denominator, and we have to see who is the troublemaker, who's going to cause a problem, who is not allowed in the domain club. So you go 4 minus 9x, and you find out what makes it a 0. So I'm going to subtract 4, and there's negative 9x, and that equals negative 4. Divide by negative 9. Was done too. And we get x is equal to Negative over negative is a positive. So positive simplified, 4 over 9 is lowest term. And that means if I plug in 4/9, that fraction, it makes the denominator 0. 9 times 4/9 is 4. 9 times 4 over 9, the 9 cancel, so this would be 4 minus 4 here. And I'd be dividing by 0. So you have to solve for the denominator, let it equal 0 and solve it. That is not going to be allowed. If we wrote it out in words, the domain would be all real numbers except x cannot equal positive 4 over 9. Again, you're going to have a little bit more room than I have right now. I need to see the solving. I need to see that you solved it, and you see that one. And now we need interval notation. I'm going to scroll this up just a little bit, which means it's going to be nothing. Let's take that. So we just got from here, x is everybody except 4 over 9. Sometimes a number line helps you put it into perspective. It'll help you see what you're going to actually write up as an interval. You don't have to do this, but I recommend it. Here's 0 on the number. 4/9 is just a positive number over here. So here's the number 4 over 9. 4 over 9 is the only number not allowed. So it would be an open circle, and everybody to the left works. That's in the domain, and everybody over here to the right would be in the domain. Everybody except 4 over 9. Okay? So the interval notation from left to right, down there, the number all the way down there to the left on the number line, that's negative infinity. So the domain goes from negative infinity, and it goes all the way up to 4 over 9, comma, 4 over 9, and then a parenthesis. If it does not equal a number, it's a parenthesis. Maybe a little bit more, a little smaller, so have more room. So negative infinity to 4/9, parenthesis. Now, I'm going to leave a little spot here because I got to put something in between. Just hang on to, leave a little room. On the right-hand side, these numbers start parentheses at 4 over 9, and they go forever to the right. Now, forever to the right is positive infinity. Infinities are always parentheses. Parentheses mean you don't equal that number. You cannot actually equal that number. So we can't equal 4/9. That's why it's a parentheses on the 4/9. You cannot equal infinity. That should hopefully be obvious, because as soon as you think you're at infinity, then guess what? It's one more that way. And so, hey, I'm at no, it's like 2 more that way. I'm at infinity. Well, it's an infinity more that way. So as soon as you think you're there, you can still keep going. So you can never get to infinity. That's why it's parentheses. Okay? If we can equal a number, if we had something that was x was greater than or equal to 5, so on a number line, we'd have a solid circle on the 5 because 5 works, and everything is greater than that, so you would shade to the right. So the interval would be a bracket on the 5. all the way to infinity. The interval notation for an equals is a bracket, but infinity is always a parenthesis. Okay. Because it's all of these and all of those, or all of those, these are the domains, we've joined them together with that symbol. This is a union. That is a symbol for the union of those two sets. Remember, the domain is a set of numbers that we're allowed to use in our function. It's the set of these numbers joined together, union with those numbers. That is not a U. This is the symbol for union. It just happens to look like a U conveniently. And you have to have that because that's how you join those two sets together. This is a class for STEM majors. If you are going on, you need to know the language to represent these values. You got to speak this language. You have to be able to write the answers using this language. So you can't fight it. You have to be able to learn it. But any question about the first practice? Then another function. Might always be a good idea to actually understand what you're about to plug stuff into, read it before you actually substitute. G of x is equal to 5 minus 2x, and then you square it. So whatever you substitute, order of operation, whatever I plug in for x, I'm going to multiply by 2, 5 minus 2 times that value, and then I square it. 5 minus 2 times the substitution, and then I square it. So G of 9, I want to see 5 minus, so parentheses, 5 minus 2 times 9, and then it's going to get squared. So order of operations, you got to do what's inside first. So this is equal to 5, 2 times 9 is 18, minus 18 squared. 5 minus 18 is negative 13 squared. And look how important it is to keep the parentheses. Negative 13 squared is positive 169. You could come up with the correct answer, but if you don't have the parentheses around the negative, it's not the correct word. In other words, you get the negative 13, but you don't put parentheses. And so you go from here to here. This is absolutely incorrect. The square of negative 13 is not 169. This square is negative 169 if you don't have parentheses. That's a false statement. You have to keep bringing that parentheses with it until you actually do the split. Any question? So I'm showing you exactly what I expect to see from you. G of -6. So 5 minus 2 times, so this is going to be 5 minus, parentheses, 5 minus 2 times a -6, and then we're going to square it. So in the parentheses, this now becomes parentheses 5 plus 12 squared. Because a -2 times a -6 is positive 12. And so in the parentheses, we now have 17, and then we're going to square it. Now this time, it's actually okay if you wrote parentheses 17 squared, or if you went to just 17 squared, because there's no negative to have to keep in the parentheses. Is it safer to make sure you do the parentheses? Yeah, it's safer to do parentheses. And 17 squared is 289. But from the bottom of the box, final answer goes here, 289. Show the substitution, then show how you simplify it in your final answer. Question. So g of x is the function. You take 5 minus 2x and then you square it. I want to replace x with x minus 3. So if I'm going to replace this x right here with x minus 3, then every x gets replaced with an x minus 3. And you do order of operations and so on. So we have a parentheses, 5 minus 2, and now I'm going to replace that x with an x minus 3, times an x minus 3, and then that whole thing is going to get squared. So the only thing that happened was this x is replaced with that x minus 3. That's it. Just the substitution. Now we simplify. So this g of x minus 3 is equal. You still have a parenthesis. In the parentheses, you cannot subtract the 5 and the 2. You got to multiply first. So this is 5. We distribute the -2. -2 times x, so minus 2x. -2 times -3 is positive 6. And then we're still going to square it. D of x minus 3 is equal to, the way you should write it is your X should be first. Your term with an X in it should be first. So that term is a negative 2X. And then the constant, we have a 5 plus a 6. 5 plus 6 is positive 11. And we're still squaring this now. Now you got to multiply that out. If you decide to use the shortcut, the special product, then you would have ended up with positive 4x squared minus 44x plus 121. That's what we did last week. When you square this, it's negative 2x plus 11 times negative 2x plus 11. So we distribute. This term times that term, we distribute the negative 2x to both of those. So I'm actually going to write it out. It's this negative 2x times that negative 2x. And then it's this term times that term, distributed to both. So it's this negative times a positive, which is a negative, 2x times that 11. So negative 2x is multiplied with each of those. So now we distribute the 11 to both of them. A positive times a negative, that's a negative. 11 times 2x. And then last times last, a positive times a positive is a positive, and that's 11 times 11. Right here, negative times a negative, positive. 2x times 2x. 2 times 2 is 4. X times x, x to the second. A negative 2x times 11 is a negative 22x. A negative 11 times 2x is another negative 22x. Plus 11 times 11 is 121. Combine your like terms. The only x squared term is the 4x squared. These are both x to the first. So we have negative 22x to the first, another negative 22x to the first. So negative 22 and negative 22 makes negative 44 of those x to the first, and a positive 121. Substitute and simplify. Questions there?
So when we do the student power, we're always gonna basically write the 2x plus 11 lines when it's an example like this.
Yeah, anytime you do a square, you have that times itself. So if it was to the third power, I'd have 3 of them multiplied together, which you can't, nobody, no matter, the smartest person on the face of the earth cannot multiply 3 things all at the same time. You multiply 2 of them, get that answer, and then you multiply the third one in. Now, there are special products, just like how I did this in my head, there's a special product, the ones I went over last week. So there are ways to get to the answer without multiplying 3 things at a time. That's a story for another day. Okay. Domain. Well, the denominator cannot equal 0. So we take the denominator and we say, all right, who's not invited to the domain party? We go 5x plus 8. Let's find out who would be the troublemaker, who we got to kick out, and we solve. Let the denominator equal 0 and solve. This is exactly what I want to see. So you subtract 8, and then it gives you 5x equals -8, divide by 5. So when x is equal to -8/5, not allowed. That would make 0 down below. And again, it's not required, but it helps. If I'm going to write interval notation, a number line does help because you can visualize what's going to actually happen. There's 0. -8/5 is over here on the left. And since it's not allowed, it'd be an open circle. There's -8/5. And that's the only number not allowed, so you shape everything except everything this way, down that way to -infinity, and everything to the right, all the way to +infinity. So what is shaded from left to right, they go from -infinity all the way up to -8/5. Parentheses, since it's not allowed, join together, union, and then it starts again from -8/5, and it goes forever that way to +infinity. And those are the numbers that are allowed. We can plug in everybody except -8/5. Question on that domain. So there's 4 parts to the quiz. One, two, there's 3 parts here on part 1 or question 1, and then there's this one. So there's 4 questions, basically. 6 points apiece. It's a 24-point quiz. And then you have 2 bonus questions. 1 question, but 2 parts. 3 points each. So you can max out 30 out of 24 here. It's a piecewise function. And all you're doing is substitution. You got to plug the value into the correct piece and then evaluate. Most important thing is you understand what this piecewise function is telling you. First thing, you never plug it into both pieces. That's not what's going to happen. You're given one value to plug in. You have here 2 pieces. You're only going to plug it into one of the 2 pieces. It can't go into both. Because if it's a function, x can't be in 2 different parts. X can only go into one piece. If x repeats, it's not a function. So what determines which piece it goes into? It's inequality. That tells us when we're going to use these two pieces. F of x is equal to this first piece. If whatever we're going to plug in, we're going to plug it into 6 minus 5 over 2 times x. If we're given an x that's less than negative 10. So if I'm given a value that's less than negative 10, I plug it into this piece of the function. F of x is equal to negative 2/5 times x minus 1. If I'm given a value that's greater than or equal to negative 10. So I use the second piece if I'm given a value that's greater than or equal to negative 10. So the piece that I plug it into depends upon what I'm given to plug in. So when I come over here to do the first question, and I'm told to figure out what is f of negative 10, so I'm actually going to plug in negative 10. You go here first. Is negative 10 less than negative 10? No, it's not less than itself. Is negative 10 greater than or equal to negative 10? Yes, it equals negative 10. So negative 10 is on this interval. Negative 10 is in this domain. Negative 10 is going to go into this function only, into this piece only. I only use this piece of the function for values that are greater than or equal to the negative 10. So I'm given negative 10, so this is the one it goes into. Over here, I'm going to use negative 2/5, so we have C the substitution. So this is negative 2 over 5, and then times x, so I'm replacing it with a negative 10, and then a minus 1. So I want to see that. And then a negative times a negative is positive. So 5 goes into 10 2 times. 2 times 2, that's 4 minus 1. 4 minus 1 is 3. F of negative 10 is 3. That's all that happens. F of negative 12. Well, guess what piece negative 12 is going to go into? Probably the one that we didn't use, maybe not. As bonus, it doesn't have to follow this way. But if you're not sure as to which one it's going to go into, you can always do this. The number that separates your function is negative 10. So here's negative 10. You have left and you have right. Negative 10, the first number I plugged into was this one. It was right on the negative 10. This has the equals, that's why I plugged in here. Now I'm going to plug in negative 12. Which side is negative 12 on? Left or right of negative 10? It's over here. Is this side less than or greater than the negative 10? It's less than. So it's going to go into here. Negative 12 is on this function. It's on this piece. So if you need to see it on the number line so you know which one you're going to plug it into, why not? Because you want to get it right. You do that enough times and then you don't need to draw that number line. Or you just keep getting it wrong and wrong and wrong. You don't know why you're getting it wrong because you're guessing. And if sometimes you get it right, well, you've guessed right, but that doesn't mean you're going to guess right the next time. You want to have a strategy that's always going to work so you have the confidence to get it right without seeing the number. So it's going to go into this first piece. So it's going to go 6 minus 5 over 2 times the x. So this is going to be 6 minus 5 over 2 times that negative 12. Show the substitution. just the substitution. Don't try to plug it in and simplify, just the substitution. So now we have 6. A negative times a negative is going to be a positive. So this is now going to be a plus. 2 goes into 12 6 times. So this is going to be 6 plus 5 times 6, 30. And 6 plus 30 is 36. So f of negative 12 is 36. And that's what your bonus question was like. Substitute, simplify. Take on quit. Remember, you have last week's quiz prep that's basically on the YouTube. You have what we just did now that'll get posted. You'll have the one that we go over with as many questions as we can, do from the one that I posted last week, the quiz prep that you have to do, the second quiz prep, all to help you through doing your take-home quiz. Take-home quiz is going to be due at 10 o'clock on Wednesday. And I'll go through the rest of all the directions when everybody's here at 10. Right? So it's come on back at 10.